Hi everyone. So today we're going to work on applications involving quadratic equations. And so not every problem that we're going to do is going to be solving a quadratic. Some of it may be creating a quadratic. Some we might be using properties where we square root both sides, where we solve by square roots, solve by quadratic formula, things like that. And then our other application problems may involve rationals. So we might have to multiply through by the common denominator. So it's a good review for your final, which is coming up. All right, so we're going to solve formulas for an indicated letter and then solve with applications that do involve some rationals and some quadratic equations. So when we're solving formula, we're going to use some of the principles that we've talked about. Okay, so we're going to be using solve by square roots. Okay, we're also going to use quadratic formula. And we may have to square or cube both sides, but we'll see how that goes. All right, so let's take a look at this first one. The time t required for a pendulum of length L to swing back and forth, basically completing one complete period, is given by the formula t equals 2 pi square root of L over g, where g is the gravitational constant, and we're going to solve for L. So remember, L is the length of the pendulum. So think like grandfather clock, or, you know, when somebody's trying to hypnotize, you know, they swing their pocket watch or whatever. Okay, so we're going to try and solve for L. So t equals 2 pi square root of L over g. Okay, so there's a couple of different ways we can start. We could divide by 2 pi, which I think might be the easiest way to go, or square both sides first. I personally like to get the radical by itself, so I'm going to divide both sides by 2 pi. So we get t over 2 pi is equal to the square root of L over g. Now, sometimes it may not be, you might not be able to divide, so you can square the 2 pi or whatever's in front of your radical when you square both sides. So you are allowed to do that. Okay, so now our radical is by itself, so I'm going to square both sides because it's a square root. This is where the quadratic part comes in. So I'm going to give everybody a squared. Okay, so we get t squared over 2 squared pi squared is equal to L over g. Okay, I don't think we can do much with pi squared, but we can make the 2 squared a 4. So while we're doing that, let's get rid of the g because we're solving for L by multiplying both sides by g. So we get gt squared over 4 pi squared is equal to L. And that is our answer. That's not too bad. All right, let's try another one. An athlete's hang time is the amount of time that the athlete can remain airborne when jumping. My favorite is Michael Jordan and his hang time. You have to watch the video of him going for the basket. It is just amazing. The formula relating the athlete's vertical leap in inches to hang time t in seconds is v equals 48t squared, and we're going to solve for t. So v equals 48t squared. Okay, again, I'm going to divide by 48 to start because I want to get t by itself. Okay, so we get v over 48 is equal to t squared. Okay, so now it's squared, so we have to undo that. So we're going to square root both sides. So we're going to get the square root of v over 48 is equal to t. Well, that'd be great. I would love to stop there, but we're not going to be able to because we have a radical. We got to fix this thing. So let's fix our math here. So square root of v over the square root of 48. Okay, we know from previous we got to break down 48. To me, that's 4 and 12. This is 2 and 2. This is 2 and 6. 2 and 3. Okay, so because it's square root, group of 2, group of 2. So I'm going to do all that over here on the side. So it's square root of 4, square root of 4, square root of 3. Okay. So we get the square root of v over, this is 2 and 2, or 4 square roots of 3. Okay, so we're still not done. Can't have a square root in the bottom of the fraction. Should have left more room. Okay, so we have to get rid of that 3. So what do we need to multiply square root of 3 by to make it a perfect square is another square root of 3. Okay, we multiply straight across, we get 3v over 4 square roots of 9. Well, 3v square root of 9 is 3. Again, this is all equal to t, sorry. Okay, so our last step would be square root of 3v. Let's write it up here. Square root of 3v over 12 is equal to t. All right, there we go. All right, that was a lot more involved than you would think, but the hard part was rationalizing the denominator. All right, let's do one more. An object tossed downward with an initial velocity or speed of v sub o, that's supposed to be v sub o, will travel a distance of s meters, where s is 49t squared and plus v sub o t, and t is measured in seconds. Solve for t. Sounds like one of Mr. Cameron Fowler's physics classes here. All right, so we get s is equal to 4.9 t squared plus v sub o t, and we're solving for t. So, I guess we have to, I guess it's a quadratic formula. We're going to set this equal to 0. This looks really, really nasty. Is that positive 4.9? Yes, okay. That can't be positive. I guess so. It's a negative s though. All right, so let's do A, B, and C. A, B, C. Yes, here, because it's a formula, we are going to have letters, which we don't usually do. Okay? All right, so let's see what we can do here. So we're going to get x or t equals negative v sub o, plus or minus the square root of v sub o squared, minus 4. A is 4.9, c is negative s, all over 2 times 4.9. Okay, let's see what we can get. Negative v sub o plus or minus the square root v sub o squared minus, what is that, 19.6. Negative s is going to make that plus over 9.8. Okay, that's as far as we can go. That is ugly. Okay, all right. So notice no numbers or anything in there. All right, let's try some solves, okay? All right, so let's do those. So when we're solving here, we're going to be using quadratics. Okay, so we may be using quadratic formula. So let's say quadratic formula, square roots, taking the square root of both sides, things like that. We're going to be using our solving techniques for quadratics. All right, you also may be doing some rational expressions, which means multiplying through by the common denominator. Okay. All right, so let's try this first one. If Fiona rode her motorcycle 300 miles at a certain average speed. She traveled 10 miles per hour faster. The trip would have taken 1 hour less. Let's find Fiona's average speed. Okay, so, I don't know, let's see. All right, so her distance is 300 for both, okay? But she had traveled, okay, so our rate, we have x and then x plus 10. And time, all right, let's see what we're going to be able to do with that. Time, how are we going to do that? So our distances are both equal, okay? All right, let's fill in the chart, make me a little better. Okay, our distance is still 300. Our rate, first time is x, and with the additional time, it would have been our additional rate. X plus 10. Our time, t minus 1. Okay, so what does that mean? Okay, so x is equal to distance equals rate times time. So that means rate is distance over time. So 300 over t, and x plus 10 would be 300 over t minus 1, or 300 over t minus 1 minus 10. Oh, all right, let's see what we can do here. And then our distances are the same. So we're going to have 300 over time is equal to 300 over time minus 1 plus 10. All right, so we have fractions here, so that means we have to multiply through by the common denominator, which would be t times t minus 1. So these are going to cancel. These are going to cancel. Okay, so we get 300 times t minus 1 is equal to 300t plus 10t t minus 1. Okay, these are really, really nasty, and I think I did put another one on here. We're only going to do one. Okay? So we got 300t minus 300 equals 300t plus 10t squared minus 10t. Okay, so it's a quadratic, which means I want everything on equal to 0, which means everything's going to go on the other side. So I'm going to subtract the 300t. Oh, look at that. We can just cancel those babies out right there. And I'm going to add the 300. Okay, so 0 equals 10t squared minus 10t plus 300. Okay, so I don't know about you, but I'm going to get rid of the 10. So I'm going to factor out the 10. Okay, so that 10 is kind of just a multiple. So I can ignore him and just go t squared minus t plus 30 is equal to 0. Oh, we can factor that. Minus 6 plus 5. Okay, set them both equal to 0. So we're going to get 6 and negative 5. Okay, so it wouldn't make any sense for time, right? Because that's it. Would be equal to a negative number. So he's out. Okay, so would 300 divided by 6, our rate would be 50 miles per hour. And that would make sense. Okay, or 5 hours, sorry. Yeah, 50 miles per hour, that makes sense. And 300 divided by 5 would be 60 miles per hour, so that makes sense. So we want to make sure we answer the question. Okay, so our rate would be 50 miles per hour, and then with the additional time would be 60 miles per hour. Okay, we're going to stop there. We're not going to do the second problem. All right, guys, let me know if you have any questions. Stay safe, and I'll talk to you again real soon.